Alright, so we'll take a look at the groundwater model here, which is demonstrating the water cycle. We have our precipitation, as you can hear and see, coming down, and it's hitting the land surface and recharging our aquifers here. And I'll just briefly talk a little bit about what you're looking at here. So we have a fractured rock geology. You can see these lines in here, and I'm going to add some color here to give us a little bit better view of those fractures. Okay, and you'll see that blue dye begin to travel through the fractures in the rock. So as rock forms, and over time pressure and temperature changes creates these fractures. And for deep wells that are in fractured rock, that's where the water's coming from. As you can see here, it's coming up into this well reservoir, and then it's being pumped up. So in contrast, in our coastal plain areas, we have sand and gravel aquifers, and the water is actually coming in between the pore spaces in between the sand and the gravel. We have here what's called a confined artesian aquifer, and the reason it's confined is it has this aquitard or confining layer of geology, which could be very compacted soil or rock. And although surface water can penetrate through a confining layer, it takes many, many decades or centuries for that water to finally get through that layer and down into the lower regions. Then we have above the confining layer what's called unconfined aquifer, and that basically means that it's in contact with the surface water directly. And so therefore an unconfined aquifer could actually be at greater risk of surface contamination, and we have a little display for that here. This is an underground storage tank, say something like a fuel tank, and right next to that we have a septic system that we'll add a little color to kind of see how a septic system normally works. It's starting to work already pretty good. We have water in the septic tank, and then it's going out to the drain field and percolating down through the soil, and that's where the bulk of treatment is happening. Okay, and that's exactly what it should be doing. As it goes through the soil, it will break down, the organics will begin to break down, the nutrients will break down or be converted. But the issue can be with either a failing septic system or a underground storage tank, or even say an abandoned well. It can have direct contact with surface waters. As you can see, already we're getting a little bit of red color here. So if we were to have a shallow well, such as this well right here, you see, if we were to simulate turning on our well pump, you can see we're actually going to draw in some of that contaminated water potentially, whether it be from a abandoned well, a storage tank, or a septic system, whatever the case may be. So again, you have protection if you're in a confined aquifer. If we tried to pump up here, let's see, we're not getting any of that contamination into that because that confining layer is protecting it. The other thing you'll notice is that, again, water is essentially, all water is connected. And so what you're seeing here is potentially surface contamination getting into the lake, as well as it could potentially get into the the springs and surface area. So like in Maryland, approximately about 60% of the base flow of streams is coming from groundwater. So that's why we like to say that all our water is connected. And so this model basically demonstrates a couple of things, not only surface contamination, types of aquifers, but that connectivity, I think. And also the other thing that it demonstrates is that groundwater moves. And that's what you're seeing in this particular case with the red. You're seeing groundwater is moving, and that could be because of elevation, pressure, lay of the land, whatever the case may be, but it does move. And it can actually change direction depending upon uses. So if you had a large well, you can actually shift water from naturally goes this way over in this direction. So again, water's moving through the geology, albeit very slow, but there's a lot of dynamics that come into play with groundwater.